Please welcome Arnaud Robert.
Good afternoon. Thank you for coming at the end of the day. I appreciate it. We're going to start with a bit of a vision of the future. You can imagine a factory where it's all about robots. Now, we can debate if and when this will happen, but I think we would all agree that a version of this is at the doorsteps. The main reason for this is that we're seeing a massive transition from automation to autonomy. If you were the keynote this morning, I briefly talked about it, but we're seeing on the left side, obviously stationary robots. They can do a single task very efficiently with high accuracy, high speed. Then we moved into the middle section, the AMRs, which added, I would say, a certain level of mobility and a certain level of autonomy, mostly used in warehouses and logistics. Now we're entering the age of humanoids, versatile, multi-purpose robots. So of course that brings a lot of autonomy to the factories. There are two enablers of the humanoid era that are quite critical actually, and that really frankly happened only in the last, let's say, 18 to 24 months. The first one is on robotics. We're seeing extremely high-performing actuators coming to the market that we've never seen before. What does that do? It allows the robot to move very smoothly and with certain speed. And then the second big thing we've seen in the last 18 months is that the hands are getting more and more dexterous, artificial hands, bionic hands, which means that if 2 years ago a robot would have a pretty hard time picking up an object, now they can go and pick up a bolt or a screw. Right? That's a massive difference, massive improvements. On the right side, it's physical AI. We've all heard about it, we have seen it, but really in the last 18 months, the pace of innovation is unprecedented. There's a few things that are happening in physical AI that are particularly relevant to robots. The first one is foundational models. You've all used ChatGPT, yes, or form of ChatGPT. And you've heard about LLMs, large language models. There's a similar thing for robots, foundational models, which teach the robot how to reason. As an example, if the task is go scan the door, those models will break it down for the robot. To go scan a door, I need to find the door, go to the door, scan the door, come back. This didn't happen before. So now instead of programming all this, we can use those foundational models to feed the robot. The second one is the next step. We call it the VLAs, Visual Language Action Models. Similar idea, but now you're breaking down the specific task into what do I need to do. When I'm scanning the door, for example, I need to move the arm, move it forward, backwards, up, down, etc., etc. All this through a model. Again, 2-3 years ago, you would have to program this and all the different permutations. Now you don't anymore. And then the third one is edge computing, specifically for AI. Again, if you look at 2 years ago or so, most of it had to be done in the cloud, which means the robot couldn't really be autonomous, fully autonomous, had to be connected, and so on and so on. Now, actually in Aeon, we have 2 full AI computers in Aeon to do all those things locally, much faster, quasi-real time, and so on. So that has changed quite a bit the landscape, as you can imagine. This morning, we had the pleasure to introduce Aeon, and we like it so much that we'll do it one more time. And you'll see that it's quite a feat of engineering. And with this, let's reintroduce Aeon.
It's time for Aeon. Agile, versatile, aware. Agility, to work with dynamic precision. Versatility, learned through experience in real time. awareness through spatial intelligence to sense, recognize, and take action. It's time. Let's get to work. Aeon.
Excellent. Yes, thank you. Thank you. And you see a few units here, so we'll get them in action pretty soon. The three things you have seen in the video are really critical, and it's really the foundation of how we built Aeon: agility, awareness, and versatility. So I think it's important that we just unpack that a little bit so you understand how Aeon was actually built. The first one is agility. Agility is really the combination of two things: dexterity and locomotion. Dexterity is about how we can move in space. So we have 34 degrees of freedom. Think of an elbow, 1 degree of freedom, a wrist, 2 degrees of freedom, and so on. So 34 degrees of freedom allows Aeon to move into space with quite agility, right? But it also needs to move at a certain speed, backwards, forward, pivot, and so on, and that's agility. Locomotion for Aeon was on wheels. If you were there this morning, we talked about the wheels. We tried feet, we tried belts, we tried many things, but the wheel is effectively the most efficient locomotion system in the setting of an industrial, right? Whether it's a factory, a warehouse, logistics, where you may have to do certain distances, you may have to pivot to use case, and so on. So dexterity plus locomotion equals agility. The second thing we did was spatial intelligence. So Aeon has way more sensors than any competitive humanoid in the market, partially because that's the inherited of Hexagon. We know how to do sensors and do them well, and also because spatial intelligence is quite critical for humanoids. Spatial intelligence, in our case, is 22 different sensors in Aeon, 12 different cameras, also IR cameras, microphones, and so on. Why 22? Because it gives us a full range of understanding of the world around it. And so the challenge, I would say, was that what do you do with 22 sensors? It's what is called, bear with me, multimodal sensor fusion. So think of us as human. At the moment, your eyes and your ears are probably more focused, hopefully, on the stage than everywhere else. But that's really because we have trained as humans to focus on what matters at the moment. For a robot, we don't have that inheritance of thousands of years of learning. And so the 22 sensors are basically providing the same level of information to Aeon. So we need a system that basically decides, out of the 22 sensors, which ones are important at this moment in time. It could be based on the environment you're in. It could be based on the task you need to achieve. So it's actually not that easy to have 22 sensors and then decide which ones are important. That's spatial intelligence. The third one is awareness. Oh, sorry, versatility. Sorry, I apologize. Versatility. Multi-purpose plus adaptability. What do we mean by this? If you're agile and you're aware, of course you can do multiple tasks. Sure. But what is really the key to unlock versatility is actually the training. So when we train Aeon, we use 3 different techniques. The first one is simulation. We literally have an environment where we can simulate Aeon and the environment it's working on, and then try to get Aeon to do a task. And then, of course, by simulation, we improve how it does the task. But we also have reinforcement learning. So we're teaching Aeon what to do. If it does it well, it gets rewarded. If it doesn't go well, it does not get rewarded. And it's a training mechanism that's quite well understood. And then the third one is imitation learning. Imitation learning is teaching the robot by doing instead of programming. That's quite critical and quite new, actually, in the robotics space. And it's very interesting because as a humanoid, and if you were there this morning, I talked about it briefly, the teacher, the human, and the student, the robot, if they're same form factor, every gesture you do to train the robot is directly transportable. So imitation learning is very, very efficient. When we get to the demos, you'll see there's a few demos that were 100% done through imitation learning. Not a single line of code, not a single line of programming, which was quite impressive. And of course, it allows us to train the robot to do new things at high speed. What used to take weeks of programming, we can actually train Aeon to do certain tasks in a few hours now. From absolutely nothing, no knowledge of the task, to completing the task in a few hours. So although we have quite a bit of versatility with Aeon, we're focusing on a few use cases really based on many conversations with potential customers. The first one is manipulation, where Aeon can manipulate objects, think of it sorting objects, and so on. The second one is inspection. Think of Aeon with all the sensors being able to see a part or to see a machine and detect if there's a defect, if there's an issue with the machine, if it's a red dot instead of a green dot, so it's not functioning, and so on and so on. The third main use case we have is reality capture. Again, this is really enabled by the sensor suite in Aeon. So as it roams around or in a stationary position, all the sensors are basically giving a medium fidelity view of the world, a digital twin at medium fidelity. So that's quite interesting if you're managing inventory, for example, and you need to know multiple times a day how was the inventory changed in your factory or your warehouse. And the last one, we call it operated tasks. Those are tasks that are more complex. We'll give an example and actually a demo in a few minutes, but just think of scanning a door. Quite complex task, requires equipment, it requires the robot to understand what to do, and so on. And so we call it operated tasks. Just think of more complex end-to-end tasks that the robot can do. So those are the 4 use cases that we're focusing on, but also really based on many, many conversations with our partners and customers. So far, so good, a bit theoretical. And so what I suggest is that we get Aeon to work a little bit, and we're going to show you a few demos of what we just talked about. We're going to show you a demo around locomotion. We're going to show you a demo around manipulation of objects, and we'll end up with a demo of inspection. So we're going to get the Aeons to start working. The first demo we're going to do is locomotion. So we're going to ask Aeon to come to the stage, have a little chat with me, and then on the way back, we'll ask it to do something that you'll see is special. So Aeon is coming to the stage, all good. You probably noticed, actually, the speed is actually quite impressive. And so that's what we've been working on with the locomotion. Now, Aeon, can you introduce yourself?
Hello, my name is Eon, and I am a working humanoid from Hexagon Robotics. I am excited to be here today and showcase what I can do.
Great, thank you. And what will you showcase?
Today, we will be demonstrating our locomotion ability, sorting multiple objects, and inspecting an automotive part.
All right, excellent. I say we get to it.
Sounds good. Let me get my colleagues to work.
Excellent. On the way back, we're going to ask Iga to take position. You've seen where Eon came from. Now, because it's working in an industrial setting, one of the things we had to implement was the fact that if a person comes in the way of Aeon in the trajectory, Aeon needs to recognize there's a person, avoid it, change the trajectory just a little bit to avoid the person, and then go to its place. Again, this is really enabled by the suite of sensors we have. So we literally detect the presence of a human on the path, and we do a slight adjustment to go around that person. Thank you, Iga. The second demo we're going to show you is manipulation. Let me walk over here, and we're going to have Aeon, hopefully you see it on the side screens, we have Aeon basically sorting objects. Always a bit tricky in real time, but it's all good. And what we did here is actually we trained Aeon to use both hands. which of course for us is a bit natural, but actually for a robot, it increases the complexity quite a bit. And so what we trained Aeon to do is that not only is it sorting objects, so the green to the left, the gray to the right, that's what it was trained to do, but it was also trained to continue to work as long as an object is on the table. So basically, as long as there's something to sort, Aeon just continues to work. So this, you'll see, but we can also switch positions and basically have Aeon just continue to do that work. Again, it will recognize the gray object. It knows the gray goes to the right and puts it there, and again, knows the green goes to the left and will complete the task. Of course, we can do this continuously, but it was just to give you a sense that, of course, sorting is not new in a humanoid space, but with two hands and being independent, that's quite the feat. And again, it's a combination of sensors, but also a combination of how we trained the robot. We literally trained both hands to operate completely independently. The next thing we're going to do is the inspection. So we've highlighted a car door over here. I talked about it just a bit before. So we're going to have Aeon basically inspect the car. What we've basically told Aeon is that there is a car door on the right side of the stage. It will turn around, it will see the door, and you will see that it will adjust its trajectory until it gets to the right position to scan the door. We're scanning the door with a Hexagon AS1 scanner, extremely high-resolution scanning, down to the microns. And it will do the task. There, we also trained it through imitation learning. So literally, we had Aeon learn from a professional operator how to use the scan. And once it knew how to use the scan, it can do it on its own. It will take a few seconds, of course, to scan the door. And what you're going to start seeing appearing in the back is exactly the result of that scan. So as Aeon continues to scan, you will see the door, of course, appearing. There's a little delay, of course, as it goes through the network, but you get the idea. And it will do the entire door, little by little, of course. What's quite interesting is that also what we've learned as we trained Aeon is that in certain cases, the scan might have not done exactly what it was supposed to do, and Aeon will actually detect that and then go back to the place missing. What you will see here, as an example,
I have completed the scanning of the car door.
Is that the bottom left of the door was not fully scanned. Remember, there's a delay, that's why Aeon is done. But Aeon actually went back to get that last piece at the last minute. So that's quite interesting. And of course, because Aeon is a robot, it can have the actual detailed image of that door in memory. And not only can it scan the door, but if there's a defect on the door, which means it's not compliant, or the measurements were wrong versus what it was supposed to do, the specification, Aeon can actually right away tell it, right? It has the image of what it's supposed to do, the image of what it scanned, etc. So now that the demos are over, we asked our 4 Aeons that participated to come up. And of course, you know, as any good show would be, it would end on a high note. And so thank you, Aeons, for your work. And you know, thank you for the crowd. Excellent. So a lot of work actually goes into those operations, as you can imagine, but we wanted to give you a bit of a flavor of locomotion at the speed at which we can move, manipulation, sorting objects using both arms in an independent way, and of course a more, I would say, complex task, the scanning of the door. Of course, we can train Aeon to do many other things, and we've done it in our offices, but those are, I think, is a good representation of what Aeon can do. Excellent. Perfect. Now, when we looked at building Aeon, we had a few choices, right? You can build it all yourself, or you can do it with partners and so on. And so we decided that it was really important for us and also for the ecosystem of robotics that we go with the number of strategic partners. So today we're actually quite thrilled to announce 3 very strategic partnerships with Microsoft, Maxon, and NVIDIA. With Microsoft, we're partnering on the Azure cloud and the ability to scale our training, as well as the entire development pipeline. With Maxon, we're partnering to do very high-end actuators, and more importantly, work with them on the next generation of actuators. What do we need next to make Aeon even better? And with NVIDIA, we're partnering on 3 different things. We're partnering on their AI supercomputer, the GPU that you've all heard about. We're also collaborating with them on the Omniverse, the simulation environment that allows us to train Aeon. And then the third thing we're doing with NVIDIA is Edge AI. And as I mentioned, we had 2 computers in Aeon, and both of them are from NVIDIA. So we're quite happy about those partnerships, but to bring it a bit to life, let's hear it from them directly.
Hi, I'm Andy Pratt, and on behalf of Microsoft, I am thrilled to be part of the launch of Aeon, the new humanoid robotics platform. And we've been working with you for a while now. It's incredible to see you bring all of the skill sets from your sensor development platforms, the work you've been doing with drones, and really bringing all that together into this new platform. We're thrilled to be providing you with a cloud that allows you to train in the cloud and edge capabilities to bring this whole vision to life, and working on the new breakthrough frontier work in the physical AI space. So we hope you have an incredible Hexagon Live, and we're just so thrilled to be here and be part of it.
Hello, everyone. I am Eugene Elmiger, CEO of the Maxon Group. I'm very excited to participate in the launch of Aeon today. We have been collaborating with Hexagon Robotics for over a year now, and we are impressed about what they have already achieved and about their roadmap. Thanks to deep expertise in precision measurement, sensor fusion, and physical AI, Aeon is already capable of performing complex tasks and is already quite competitive in the market. We are excited to continue the partnership to develop the next generation of actuators for humanoids to address functional safety and to power an autonomous future across many industries. I wish you a great Hexagon Live. Bye-bye.
To our Hexagon friends, on behalf of NVIDIA, I'm so happy to celebrate the launch of Aeon, Hexagon's incredible new humanoid robot. The age of artificial general robotics has arrived. Aeon is an engineering marvel powered by breakthroughs in physical AI models, sensor technology, simulation, and mechatronics. Hexagon brings craftsmanship and expertise in ultra-precise sensing and system engineering. NVIDIA works with Hexagon across every layer of the computing stack to bring autonomy to Aeon. NVIDIA builds 3 computers for robotics and physical AI. 1 computer for robot training, another for testing in simulation, and the 3rd computer for runtime deployment. From idea to deployment, Hexagon turned vision into reality at unprecedented speed. To the entire Hexagon team, congratulations. We are so proud to see what you have accomplished. And to everyone at Hexagon Live, enjoy the show.
Excellent. We should applaud them. Yes, they're not here, but they're here with us in spirit. But we're really happy with the 3 strategic partnership and very grateful. And frankly, it's helping us in the development, but also, I think, pushing the boundaries of innovation, frankly, at every step of the way. So that's very, very powerful for us. The next thing I want to talk about is that, of course, Aeon is great, but we need to deploy it and test it. And so I'm quite thrilled today to announce that we have 2 pilot customers that will be piloting Aeon in their facilities. The first one is Pilatus, and the second one is Scheffler. We're going to pilot Aeon through a number of use cases, actually very mirroring the ones you've seen. Manipulation, so sorting parts. We're going to do reality capture. We're going to also machine tending, so when the robot actually goes to a machine and makes an operation on the machine, and then reality capture. And so it's quite a moment, actually, for the team, right, and for Hexagon Robotics, when you have actually 2 outstanding and leader partnership that are willing to pilot the robot. And so we're quite grateful about what they're doing. And let's hear it from Roman at Pilatus.
Hi everyone. At Pilatus, we craft aircraft since more than 80 years. Continuous innovation and strive for perfection are part of our DNA and essential prerequisite for us as Swiss manufacturer. Our products must excel and provide uncompromising quality. Our productivity is driven by our ambition to compete globally from Switzerland. In this regard, we see humanoids as game changer, bringing more autonomy for our factories while letting our creative staff solve the challenges. Seeing Aeon in action has convinced us of its capability, opening many opportunities in our daily operation. Through our long-standing partnership with Hexagon, we have always appreciated the straightforward and innovative mindset. We are excited to be part of the Aeon's launch today and look forward to work with Hexagon Robotics. I wish you all a great Hexagon life.
Excellent. Yes. With Schaffer, we're going to focus on 3 use cases: manipulation, sorting, as I mentioned, machine tending, and also inspection, the scanning you've seen, of course, in their facility. So very excited and very grateful about those 2 pilot customers. We'll have the privilege to announce a few more in the coming months. But it's again really a moment when the robot actually gets to work effectively. Now, all this work is really not possible without a team behind it, and I wanted to take a moment to acknowledge the team. A number of them are in Zurich. A number of them actually are here helping with the demonstration. Thank you. And it's a small team, as you can tell, but very dedicated with a lot of expertise, and very grateful for all the work that they've done to get us to where we are today, which is quite remarkable. So as we look at the future, we really believe that Aeon and humanoids are a very important part of the autonomous future. You've seen today a glimpse of what that future can be, and you can imagine, you can project how far we can go. We're extremely excited, frankly, about the potential of humanoids. As I mentioned this morning, for us it's very important that humanoids are there to complement the workforce. We see that through labor shortage and aging population, it's critical actually to have humanoids do the tasks, whether they're repetitive tasks, tedious tasks, and so on, so that the factories and the industry can continue to prosper. It's quite remarkable to be here today at Hexagon Live. It's my first Hexagon Live, by the way, and it's putting a product out there, I think, is really important. Again, thanks to the team for all the work that they've done. And we're looking forward to the next few months. Quite busy for us, obviously. But with that, I would thank you very much for coming, obviously. And hopefully you enjoyed the robots. We have a booth in the zone where you can actually interact with one of them, and then you can see the other one working. And so I encourage you, of course, to go at the booth in the zone. With this, thank you again. And let's build an autonomous future together.